Okay, so this question is saying that the number of Christmas trees sold in millions were 27.1 million in 2004, and then 28.6 million in 2006, right? So you just add this number to 2004. Okay, so the first question just says, use the table to tell me the number of live Christmas trees sold in the year 2008. So 2008 would be where t is equal to 4, so I'm going to type in 28.2, right? This number right here. Now they say determine the linear regression equation. Okay, so they also say they want us to use c as the dependent variable, right? So the Christmas trees are a function of the year that the number of Christmas trees sold is a function of the years that it's sold in. Okay, so we're going to have to go to the vassarstats site. So I'm going to scroll up and right click on our class name and say open link in new tab. And now I'm going to go to the student resources, course documents, and here is the vassarstats website. Okay, so now you go to correlation and regression, then you go to data import. And now what we want to do is we want to paste the data into here. So I'm going to open a new tab, and I'm signed into my Google account, so I can just say sheets.new, and when I hit enter, it just gives me a new spreadsheet, right? So that's where I'm going to put the data first, just to make sure it's in good shape. Okay, so now if I highlight the data, boom, boom, okay, I'm going to highlight the whole table, all the data inside the table, and nothing else. I don't need those names, but I don't really have a way to get rid of them. Right click and copy, go to the spreadsheet and say paste. Okay, and it looks like it did it pretty good. So now, but the problem is that we've got each variable is a row, but vassarstats wants each variable to be a column. So we have to transpose this data. Don't worry about the words. We don't want the words, right? So I'm going to highlight just the numbers of the data and right click and say copy, and then go to a cell down here and then say paste special transposed. And there you have the data the way that vassarstats wants it. Now, you want your independent variable to be on the left, and ours is. But if it wasn't, you'd want to like copy this and select it and drag it over, right? But we don't want to do that. We like it where it is. So I'm going to select this again. I'm going to say copy. Now I'm going to go to vassarstats and hit paste. And then I'm going to click this calculate button and make sure you get numbers here. If you get NA here, that means it couldn't read the data. And you can go up here and read the details on how to fix that. But as long as you get it right, once you click calculate, you can scroll down and you're going to get, this is the table you want right here, this R squared, slope, and y-intercept. Those are the numbers that you're going to be asked to work with on Lumen. Okay, so let's go back and ask what the question said. They said write the regression round to the nearest hundredth and use the indicated variables. Okay, so they told us that the independent variable is t. So I'm going to write c equals the slope times t plus the y-intercept. So the slope is 0.2, they said hundredths, so that's 2 decimals, so 0.28, and the y-intercept is 27.28, okay? So, oops, wrong, there we go. So it's going to be 0.28 t plus 27.28, okay? So I think that's the right answer for number 2. Now it says, interpret the meaning of the slope of your regression model. So the number of Christmas trees from 2004 to 2011 increased by approximately how many million trees each year? Well, that's what the slope tells you, right? The slope tells you is telling you that it goes up 0.28 million every year, or 280,000, right? So I'm just going to write 0.28. Now they say use the regression equation to determine the number of live Christmas trees sold in 2008. So I'm going to open up my calculator and I'm going to click, I'm going to type in 0.28. Now they said 2008, right? And 2008 is going to be 4, right? So I'm going to say 0.28 times 4 equals 1.12, and then we're going to add the y-intercept, which is 27.28 equals. So now I'm going to type that answer, 28.4. So that is the number of trees in 2008 that are predicted by this equation right here. Oops, sorry. This equation right here, right? But this is the real number of trees that were sold that year, right? So the model's estimate is close, but not the same. So they say, why are those answers different? That's what question 5 is asking you. And they said the data are not perfectly linear. The regression equation gives a more precise answer than the value from the table. Now that is not true. It's not a more precise answer. It's an estimate from a model. So I don't like this answer. That's not it. This one says the data are linear. The regression equation, it says again the same precise thing. I don't like that. That's not right. So here it says the data are not perfectly linear. The regression equation gives only an approximation of the actual value, not the exact value. That statement is true. So look, they've got that as the second statement of the last two, but then you have to choose whether you think the data are linear or not perfectly linear. Well, remember, if data is perfectly linear, your R is going to be 1.0, right? That's what the R is when you have perfect linear correlation. So I'm going to pick this one. The data are not perfectly linear. The regression equation only gives an approximation, not the exact value. And then if I submit the question, it looks like we got everything right. So I hope that was helpful.